In part 2 of our lesson on verifying trig identities, you will learn how to factor quadratic trig expressions. First, a quick algebra review. When you're factoring quadratic trinomials in your algebra class, you probably learned a method either combining product pairs or the AC method. I'll do a quick review here of both of those methods. You can feel free to use whatever method of factoring you learned in your algebra class. The product pairs method involves writing the factors of the A term. Remember it's ax squared plus bx plus c. So we take the A term and write its factors underneath. So because this was 4, we put 1 and 4, 2 and 2. You take the C term, do the same thing. So we have 1 and 6, 2 and 3. Then you look for product pairs that will add up to be the B term. In this case, it worked to combine 4 times 2, which is 8, plus 1 times 3, which is 3, because 8 and 3 add up to be 11. So you take the factors of 4, and those are your coefficients for x. So you have 1x and 4x, and then attached to the 4 was the 2, so that's why the 2 went here, because it had to be attached to the 4. Attached to the 1 was the 3, and that's why the 3 was over here, because it had to be attached to the 1. And then you get your factoring. Now, if you're uncomfortable with that method, or you have a hard time with guessing and checking, you can use the AC method. So in the AC method, we take letter A and multiply it times letter C. So in this case, 4 times 6 is 24. And then we take the B term and write it here. So we take the factors of 24 and we see which ones add up to be 11. In this case, it was 3 and 8. So we take the 11 and split it up into 3x and 8x in either order. Doesn't matter. We could have the 3x first and then the 8x, or the 8x first and then the 3x. And then you factor 2 by 2. So from these two, we could pull out a 4x, and we had x plus 2 left. From these two, we could pull out a 3, and we had x plus 2 left. Now they have the x plus 2 in common, so we pull that out front, and what was left was the 4x plus 3. Both of these methods are good. Some people are very comfortable doing a guess and check like this one. It can be quicker. Some people are more comfortable doing a more rigorous structured method. I'm happy for you to do either way. In this next example, we're going to factor each trig expression. So let's do a CYU at this point. Go ahead and factor each of these expressions and then restart the video when you're ready to check your answers against mine. In this first one, we're going to take the factors of 4. So we have 1 and 4, 2 times 2. We have to take the factors of 20. So 1, 20, 2, 10, 4, 5. And now we're going to go through in an organized way, looking for the product pairs whose difference will be 11. Now the reason we're looking for the difference this time is because that 20 is negative. So we know that one of the factors will be positive, one will be negative, so we're looking for the difference. And as you made your way through the various pairs, you would have discovered that 4 times 4, we could get negative 16 from that, and 1 times 5, we could get positive 5 from that, and we know that negative 16 plus 5 is negative 11. We will use the 1 and the 4 as our coefficients of the secant term. So this will become 1 times secant of t here, and 4 times secant of t here. The 4 has to be attached to a 4. Here, this 4 will have to be attached to a 4. And because we need negative 16, we make it minus 4. The 1 has to be attached to a 5, so the 1 that's here has to be attached to a 5, and we need it to be positive 5, so we put a plus here. And there's our factorization. Now, if you had done this with the AC method, you would have said the AC term was negative 80, and the B term was negative 11. So you would have gone through looking for the factors of negative 80 that add to be negative 11. So we would have said 1 and negative 80. And the reason I'm putting the negative on the larger magnitude number is because I know my sum needs to be negative. So of course that would be negative 79. That's no good. 2 and negative 40 is negative 38. 4 and negative 20 is negative 16. We're getting closer. 5 and negative 16, there's our negative 11. So we would have split up that negative 11 secant of t into positive 5 secant minus 16 secant. So we would have 4 secant squared of t minus 11 secant of t minus 20. We're going to split that up into 5 secant of t minus 16 secant of t. The 4 secant squared comes right down, and the 20 minus 20 comes right down. Then we're going to factor 2 by 2. Out of these first two, we could pull out a secant of t and have 4 secant of t plus 5 left. Then there's a minus sign, and we see we can pull out a 4. Remember, it's negative 4 out here, so we would have 4 secant of t plus 5 left inside, and you can always distribute back out and make sure that you're getting what you had. So negative 4 times 4 secant t is negative 16t, negative 4 times 5 is negative 20. Now these two have 4 secant t plus 5 in common, and what's left over is secant of t minus 4, so you can see that we get to the same factoring. The AC method is a little more regimented and takes maybe a little longer. The product pairs method kind of involves some guessing and checking. You're trying each of these pairs until you find the one that works. Now, if you spend a bunch of time doing this and for whatever reason you don't see the product pairs, then switch over and do the AC method, because you'll end up getting there within a minute or two. Now in this next expression, the factors of 12 will be 1 and 12, 2 and 6, 3 and 4. The factors of 3 will be 1 and 3. The 3 is negative, so once again we're going to be looking for the differences between. And we need the difference between the product pairs to be positive 16. Now in this case, it's going to work out that if we take 6 times 3, we can get a positive 18. And if we take 2 times 1, we could make that a negative 2. And 18 minus 2 would give us our positive 16. So then we know that the coefficients of the sign are going to be 2 and 6. So we would come down here and write 2 sine of theta and 6 sine of theta. Attached to the 2, we need a 1. So attached to the 2, we need a 1. And that has to give us a negative 2, so we're going to need it to be 2 times negative 1. Attached to the 6 has to be the 3, so attached to the 6 here has to be a 3. We need that to give us positive 18, so we put a plus there. Now, if we were to do the AC method on this one, we know that the AC term is equal to 12 times negative 3, which is negative 36. We know that the B term is equal to 16. So we come through and we say negative 1 and positive 36. Again, I know the smaller magnitude is going to be the negative because my B term's positive. They have to add up to be a positive. So that's not it. Then we would have minus 2 times 18, and there it is because those two add up to be 16. So let me start by just writing down the original problem here. 12 sine squared theta plus 16 sine theta minus 3. So these tell us how to split up that middle term. So we're going to say minus 2 sine of theta plus 18 sine of theta. The first term comes straight down, 12 sine squared theta. The last term comes straight down, minus 3. And now we're going to factor them 2 by 2. So we can pull out a 2 sine of theta here. And we would have left 6 sine of theta minus 1. Then we have a plus sign. From these two, we can factor out a 3, and we would have 6 sine theta minus 1. This should always match this, and now we factor that out front. So we have 6 sine of theta minus 1 times what remains, which is 2 sine theta plus 3. So we get to the same result, and both methods work very well. So please use the one that you feel most comfortable with. In this example, we will factor each trig expression, and each of these expressions is one of the special products you learned in your algebra class. Looking at this first one, cosecant squared of x minus 6 cosecant of x plus 9, you will need to practice recognizing that this is a perfect square trinomial in the form of a squared minus 2ab plus b squared. One of the easy ways to test for that is to take the c term, find its square root. We know the square root of 9 is 3, and then double that. That's what this is. Double it. Doubling 3, we get 6. So if we take that 3, which is the b term, and we multiply it times a, which is cosecant, and double it, we get 6 cosecant of x. So this will factor out to be cosecant of x minus 3 quantity squared. And you should always double check. We know that using this rule, we're going to get cosecant of x squared. Then we have to double the product, and because of that minus sign, we're going to get a minus here. Well, the product is 3 times cosecant x, and if we double it, that's a 6 cosecant x. And then we have to square the b term. 3 squared is 9. In this next example, this is also a special product. In this form, all the terms are positive. Again, a quick way to check, the square root of 1 over 16 is 1 over 4. Double that, you get 2 over 4, which is a half. So this is going to work out to be cosine of theta plus 1/4 squared. And again, always multiply it out to check. So we get cosine squared. The product would be 1/4 cosine theta, and you double that. So 2/4 is the same as 1/2 cosine theta. And take the b term and square it, you get 1/16. This last one is the difference of two squares. So we know that this will work out to be cotangent of s plus 2 times cotangent of s minus 2. And as always, check your result. First times first gives you cotangent squared of s. Outer gives you minus 2 cotangent of s. Inner gives you plus 2 cotangent of s, so those will cancel out. And last times last gives you the minus 4.